In this section, we're going to begin with a very simple program to introduce some of the concepts necessary for all programs. We'll take it simply at first to build confidence, and then we will move on to more complicated programs as the course progresses. We're going to first compute the area of a circle. This is well understood. It follows a mathematical formula that has been around for a long time. It's a good problem to start with. We understand what we need to do. The algorithm is already designed for us. But rather than just starting coding, let's understand the problem, the algorithm, and then why the programming is the way it will be. So the algorithm needs to encompass more than simply a computation here. While that is truly all that's necessary to compute the area of a circle, with a program, there are more steps. You don't just simply compute and be finished. There's more to do. For example, we must have some sort of input for this circle's radius. We must know what the radius is. So that is a step. Determine the radius. We need to verify that the radius is valid. A negative number does not work, although it appears that we can compute with it. It is not correctly done because that's a misunderstanding of the problem. Problem analysis says we must have a zero or positive number because circles are either non-existent with a zero radius or some positive radius. And finally, once we've computed that value, it does us no good unless we are able to output it in some way to the user. The user's interested in the answer of the computation, not just the fact that the computer was able to do the computation yet receive no benefit from it. So here's some steps. Step 0 is add the boilerplate. Now, boilerplate is a term that means all the necessary code to have a syntactically correct program. In larger programming contexts, boilerplate often includes such things as setup and teardown of connections and other resource-oriented code that, while it's critical to do, it distracts the programmer from solving the problem. It's important to do. It has to be done. Can't write a program without it, but it doesn't seem to directly affect the program you're writing at all in the problem analysis or the algorithm. It's just required. We'll do that, and we try to keep it to a minimum, but there's a certain amount necessary. For example, each class needs to have a name. That's an identifier we programmers choose. It has to be syntactically legitimate. Usually, I name programs in some meaningful way, like a circle area would make sense here. But since I'm following a textbook by sections, I'm actually going to name my programs on the section. So if the code is obtained by a student, they know exactly which section that code goes to. The class definition, there's a number of elements to that must be done in order for the compiler to agree that it's a legitimate program. We have to add a main method. The main method is a special method that is the starting point of our program. If we have multiple methods, but we didn't know which one to start with, we couldn't guarantee that our program would run correctly. The agreement is we always start in the main method. And for the earlier parts of this course, we're only going to write code in the main method. Later on, we'll branch out and do more interesting coding. But first, we'll start there. Until all this boilerplate's in place, we can't compile, certainly can't run. Okay, step 1 here. Let's input a radius into our program. Now, typically input is through a keyboard or some other device. At first, we're not going to do that. That's actually next section. This time, we, the programmer, are going to enter the value of the radius. I'm going to jump to Eclipse. We can begin coding this. As you see here, I have the boilerplate. I have line 1, public class driver. I'm calling this class driver. It's in the project section 2.2, if you see that highlighted right there. The class name is driver. That will become clear later on in the course as to why I call it that. For now, just accept it. Line 2 says public static void main string array args. That's required. We don't have a choice in how we structure this. It has open and closed braces, lines 2 and 4. Part of boilerplate, just has to be there. So inside of this, we will begin to write some code. And the first thing I need to do, as I said, is to define a radius and give it a value. So because a radius can have a fractional part, a decimal portion, like a half or a quarter, I need to choose a data type that represents that. So I will use a double, and I will call it radius. We need to name things sensibly, and radius seems like a good choice to represent the radius. Now I put this symbol. It's something every programmer has to go through mentally and not call that the word that starts with E. Now, I know you want to, because from algebra, that's what it's called, but not here. This is called assign. This is the assignment operator. What it will do is it will take the left-hand side, the variable called radius, and assign to it an initial value, a beginning value. We're not going to change the value, so it will stay that value, but we're going to assign it 2.5. So this means we have a circle with a radius of 2.5 units. Centimeters, inches, I don't know. We don't care at this moment, but it means 2.5. Radius is assigned the value 2.5. Step 1, we've determined the radius. Here's an interesting point about mathematics and programming. Programming was developed as a way to use a computer, and computers were developed as a way to do mathematical computations. So it would seem like the mathematical world and the programming world should be very, very similar, and they are. But because a machine is a limited device, what we cannot do is we cannot have most real numbers, for example, represented in a program. So what we use is a data type like double that approximates real numbers. Remember, there are an infinite number of real numbers. If we count all the real numbers, we say there's an infinite number. Well, a computer can't represent infinity. It doesn't have space in memory to have an infinitely large or infinite number of numbers. So we have to approximate everything when it comes to real numbers. And if we're using integers, we can represent them exactly in a certain range. We just can't have these very large integers. We just don't have the memory capacity, even if we have gigs and gigs of storage. Mathematically speaking, we can't represent most integers. So we get a subset, a small number of possibilities. And it may appear large to our minds, but not to mathematicians. We're going to approximate real numbers. The value 2.5 is pretty easy to represent, but there is a possibility the machine will not represent it exactly as 2.5. It might be 2.4999999 simply because of the way bits represent it. Doubles are approximations, and we can only approximate about 15 digits. And then we're limited to exponents of about 308 plus and minus. And if a number is larger than that, we can't do it. We have to do some other scheme. A variable is a location of memory that remembers this type of value. We as programmers don't care where it's located in memory, just that it's available for our use. And the way we access it is through that name that we gave it, like the name radius. So that's why we name our variables. So it allows us to think about those memory locations as values. We know that radius is storing value. We have the value. Now we need to do the computation. And here we have the formula A equal pi r squared. In this case, it's not an assignment operator. This is mathematical expressions. That's an equal sign. When we're programming, it is an operator that assigns a value. So we're going to have to translate between the two different meanings based on the context. Are we doing math or are we doing programming? We can't just stick this formula in the program. Something very similar to it, but not exactly this. So we have to learn how to translate this into something legitimate in the Java language. Thankfully, it's not hard. Just a point, squaring is a number multiplied by itself. So if the number's 2, we say 2 times 2. That's 2 squared. Use a Google search, for example, look up the value of pi and enter it and put about 15 digits or something. You could do that every time. But it's easier to use the defined value of pi from the math package. And we'll do that. That way you don't have to remember, and it's simpler to use something that someone else has already written. And once we do the computation, we need to remember the value of that computation so that we can then do something with it, like output it to the user. So let's do this part. Let's do the formula, do the computation, and remember it. What I'm going to say is double area assign 2.5. Now it's pi r squared. So let's do pi. I should have done that first. Math.pi times radius. I could say 2.5 times 2.5, but that solves all of a sudden only one problem. That only solves the problem where the radius is 2.5. The way I have it here in line 4, I say pi times radius, allows me to go in and change the value of radius to a different value, and the computation in step 4 still works. If step 4 said pi times 2.5 times 2.5, then I would have to change that 2.5, and there's no point of having the radius variable. Line 4 says, let's remember in the variable area the computation of pi times radius, pi r squared. We've done this computation. Let's go to the next step, and that is to output this computed value for the area. We know it. Now we need to make it visible to the user so that he can do something with it, if nothing more than just be amused by the fact we did the computation. Now, we could just output the value, just a number, and that's certainly legitimate. Good output for a user includes additional explanatory text to say what we're outputting. Make it clear. Here's a difficulty that many programmers have, and some carry it on all of their career, is they will do good programming and do good math and computations, but do poor interaction with users. The user is not the programmer. So he doesn't know what the program's doing, nor should he. He just wants to use it for its benefits. A programmer has to remember that a user, a different human, is going to use his program and doesn't understand all the steps the programmer did. We have to make it clear what we're doing and sometimes why we're doing a step. In order to keep the user from having to guess, let's tell him what we're doing. We need to explain this, and we will use text to do so. And sometimes we need to join text together to make a larger string. We'll take fragments and join them together. Java provides the plus symbol that will concatenate or join together multiple fragments of text into one larger string. The original strings are not affected. We just create a newer, larger one. And what we're going to do is we're going to output the message something like the area of the circle with radius, whatever the radius is, and then put out the area. The thing is we can't take that computation result that we've stored in the variable area and just output it, because it would be just a pattern of ones and zeros, bits. It would be 64 of them. Nobody can read that. So what we do is with this concatenation operator, Java says, you have a number, you want to convert it to text, to represent those digits like 1 and 5 and 8 and something like that. It will do that. It will take that bit pattern and translate it to text and output that. And the human reads it and says, oh, I see the answer. You must be aware that there is a conversion step that goes on because numeric values cannot be directly output. They have to be converted to text. Here's our computation. Now let's output it. We will use the system object, and system represents your entire computer. Then we'll use the out object of that. And that means the output, which is the console screen. In this case with Eclipse, it actually gets captured and we'll see it down at the bottom window, that long, thin, horizontal window. That captures the output. Okay, what are we going to do? Well, we're going to print something. So we say print, and we want to finish the line essentially pressing the enter key or the return key, which means go down to the next line. So we're going to say print with a new line at the end. And then in parentheses, we're going to say some stuff like the area of the circle radius. Well, when I put a space, radius what? What is the radius? Well, I could just type in 2.5, but again, that would only solve this problem when the radius is exactly 2.5. That's inflexible. So let's use the variable radius to hold the value. Let's just put output whatever the value is. And we're going to join that to some more. The area of the circle with radius, whatever radius is, and now we want to output the area. And then let's, just for good English, let's put a period at the end and a semicolon. I have to have the semicolon to say this statement is now complete. Right? It's like a period on a normal English sentence. I'm going to save this and let's run it. An IDE like Eclipse helps you by showing you errors. I see no errors. There's no red squiggly lines or something. Doesn't mean there aren't any problems. It just means there's no syntactical errors. Let's run it by clicking this run button. And down here at the bottom, we should see some output. All right, the area of the circle with radius 2.5 is 19.63 blah blah. Now I spoke about approximation. A double approximates real numbers. This actual result would have many more digits. Actually, it would have an infinite number of digits going to the right. But notice how it just chops it off after probably a roughly 15 there. It's because, again, our machine cannot represent an infinite number of digits. Pi is an irrational number that never terminates. It has an infinite number of digits. So when we multiply that by 2.5, the result will have an infinite number of digits. We can't display them all. We can't know them all. So we approximate them. Now, if you and I were going to paint a wall and we needed to know how much paint to use, and this was our computation, this is more than we need because we can't, use numbers more precise than this. So generally for real world problems, these approximations are extremely good. My point was, from mathematics, we must understand we're only approximating numbers when they're doubles, and then we'll output circle's radius 3.5 is 38.48. And notice I only changed the value in line 3. It used that value, it remembered it, and just used it. Our problem was to output the radius of a circle. Our analysis of it was to use the mathematical formula, area equals pi r squared. Our algorithm was determine the input value, the radius, do the computation according to the formula, output the result. And the code follows that algorithm exactly. So we did it in 3 lines of code. We had 3 steps in the algorithm. Nice, easy problem, but it shows you that there's a lot more behind this. We don't just write a program. There's a lot of thinking that goes on behind it.